Hello everyone, my name is Aran Islam and this is my video report for the first lab. Now the purpose of this lab is to investigate charge polarization and electric forces with tape. And my preview for this lab is that I found that each piece of tape had a positive charge of about 1.3 times 10 to the negative 8 coulombs, which means that there was a deficit about 2 times 10 to the negative 7th electrons. Now, in order to complete this lab, we must first review some fundamental concepts, the first being Coulomb's law, which will help us calculate forces. And Coulomb's law is equal to Coulomb's constant, 9 times 10 to the negative 9th, times the two charges over the separation distances squared. And then the second concept we have to cover is polarization, which is the concept of charge transfer from charged objects to neutral objects, which we will see later on in the lab. Finally, the last concept is Newton's second law, where force is equal to mass times acceleration, and in equilibrium, these forces will all cancel out, which we will see later on in the lab. Now, in order to calculate the lab, we must first assume some assumptions. The first being that the tape acts as a point charge with the center of charge located at the center of the tape, which will allow us to model the U-tape as a singular point charge in our coding calculations. Second of all, we must ignore air resistance, which will simplify our free body diagram and force calculations. And finally, we must assume that both charges have the same charge, which will result in ideal procedural conditions and simplify our calculations once more. Now, the experiment is that the system is the pieces of tape and what they interact with, and the surroundings are everything else, meaning other objects in the room. And then the initial conditions are that the base uncharged tape is lying on the desk, and we have extra tape to make the U-tape. Now, the procedure is to create the U-tape by smoothing out a second piece of tape on the base tape, and then pulling it off, and then observing interactions between the U-tape and several objects, such as a hand, a book, a charged pen, and another U-tape. Now, the second part of the lab is observing how U-tapes could make each other float by suspending a U-tape on a bridge, and then recording the separation distances and other necessary variables to perform some calculations. Now, the observations for this lab was that the U-tape repelled each other because they had the same charge, and then attracted toward my hands because they had like charges, and then they polarized, and then eventually attracted neutral objects because the charges gathered and then attracted to each other. But then some differences between my expectations and observations was that it was a little hard to spot attractions between neutral objects and the charged U-tape, so it took a few tries to make sure that they were truly attracted. And then all of these observations basically confirm all of the questions in the lab, which says that like charges repel and then opposite charges attract, meaning that the U-tapes are positively charged. Now, in order to determine the excess charge, we must construct a free body diagram to see what forces are affecting tape B. As you can see, the only forces affecting tape B are the force of gravity exerted by the Earth and the electric force exerted by tape A, and both of these are equal to each other because since the momentum of tape B is not changing, the net y component of the force is 0. So that means that the force of gravity and the electric force are equal. Now, in order to measure the electric force, we must measure the gravitational force. So in order to do that, we must need the mass of tape B, which is shown here. And then using this mass, we can then calculate the force of gravity as shown below, which results in a force of negative 0.002 newtons. And then we can then use the separation distances of 0.0275 meters to calculate the charge on tape B using Coulomb's law as shown below. Here's the calculation, and then the charge is about 1.3 times 10 to the negative 8 coulombs. And then using this charge, we can then calculate the number of electrons by dividing our found charge by the charge of an electron, which gives us about 8 times 10 to the 10th electrons. And then from this, we can then calculate the number of atoms on the tape itself by using the surface area and the area of an atom. The calculation is shown below, finding that we have about 4 times 10 to the 17th atoms. And then using these two numbers, we can then calculate the ratio of the electron's efficiency to the number of atoms by dividing them, which gives us a ratio of 2 times 10 to the negative 7th, meaning for 1 electron, there's about 5 times 10 to the 6 atoms. Now, in order to calculate all of this, I have some code which models it. The first part is showing all of the constants that were used in the calculations, such as details of the mass and any relevant constants. The middle part of the code is the calculations of like force, gravity, all of the charges, and all of the counts and ratios. And then finally, the last part of the code is just using to model it, which you can see here. The arrow pointing up is the electric force, pointing down is the gravitational force, and then the two spheres are the tapes. And then all of the text is just showing all of the calculations we have performed in the code and explained before. Now, the discussion of this lab is that the positively charged tape has an electron efficiency, and the net forces of the electric force and the gravitational force must cancel out. However, there are some errors which could be present in this lab, the first of which is that inaccurate measurements of anything, be it the mass, area, or the separation distances, will lead to a skewed charge due to how Coulomb's law works. But the main error that's present in this lab could be that the charges on the two U-tapes may not be equal due to human handling disrupting the charges, which will be discussed a bit later. Now, the two questions posed for the what if is that what if the electrons have positive charge and protons have negative charge? Basically, the electric fields will point in opposite directions. So for this lab, the positively charged U tape would become negatively charged and the electric field would point inward. However, the basic principles of attraction would not change. Even if U taps were negatively charged, they would repel and then they would attract the now positive pen. And then why is it important to handle the charges as little as possible? Because it will result in error otherwise. You have to handle them as little as possible because the more you touch it, the more charge is transferred between the hand and the tape, and will decrease the net positive charge as the electrons jump from the hand to the tape, skewing the lab results.